Hi, my name is Johnny Shockley. I'm a PhD candidate in the Civil Engineering program at the University of Nebraska-Lincoln. I'm a non-traditional student. I've worked between each degree that I've received. I originally got my BS in geology. I got a master's of science in civil engineering with an environmental emphasis. And like I said, I'm a PhD candidate in civil engineering. The really nice thing about learning, and I hope you realize this too, is that nobody can take knowledge or information away from you once you've learned it. And the other thing that I've learned is the more you know, the more you realize how much you don't know. And that's a progression as you go through your degree programs with the university. The less you know, the more you think you know. So when you come out as a graduate, you feel really strong that you know your discipline area, but then you soon realize that that was just a foundation and you need to learn a lot more if you want to be proficient in the area that you studied. This is just an idea, a conceptual idea of how that works. There's a lot of things you don't know that you don't know, and that's not a good place to be in. As you proceed in through your master's, your PhD, and your postdoc after you've done your undergraduate work, you find out what you don't know, and you focus more on what you do know. So you know a lot about a really small area, and you also learn that you don't know a lot more things that you wish you knew about. My advice to you as students as you go into a graduate program is to really understand, comprehend the math, chemistry, physics basics, because that is the foundation of everything else that you'll be studying. Everything can be expressed as a function or an algorithm, and that's why understanding math is so important, because as you go into a graduate program and you look at your data, usually you use some kind of function, algorithm, or hypothesis to substantiate your research works. I've also found that statistics is a very important field, especially as you work on an advanced degree. So go through the hard work of a statistics course and really understand what it is that you're saying, because it will really benefit you in the future. I also learned that there's different types of knowledges, and computer science professionals understand this. There's tacit knowledge, which is about 80% of the knowledge that you'll need as you enter into the workforce. That's personal insights, people that know about the information, where it is and how to get it, the social constructs of how the information flows, and exchanging knowledge with others. What you'll learn at the university is more explicit knowledge. It's 20% of the knowledge that you'll probably ever receive. That's the algorithms, the APIs, the formulas, the data, the models, the records, the files, the maps. Those are all things that you will learn how to process in your degree. You'll need the tacit knowledge to be able to then take and apply what you've learned in college in your profession. I also worked with a lot of really nice scientists and engineers and leaders in their areas, and found they always pushed me towards discovering new ideas and concepts by combining different domains. An example would be in water engineering. We have stationary statistical data sets, and what we're seeing now with climate variability is that they're non-stationary. So we need to reach out to other fields that look at that kind of data, for instance, economics, because they deal with financial data that's non-stationary, see how they're evaluating it, and then bring it back to our discipline, like civil engineering. You'll find that learning the science and engineering is the easy part. Once you try to apply what you've learned, the social resistance to change or convincing someone to do something that you know is in their best interest for risk reliability is a very powerful force. So knowing those tacit tools really helps you to try to transfer that information or technology or research to a social construct. I'd also encourage you to reach out and seek diverse information and opinions. That's where, it's just like the discoveries are at the boundary, diverse information can help you interpret your research and data more effectively.